I am Peter Zammit. I work at King's College London and we work on FSHD research and the role of muscle stem cells in muscle function. FSHD seems to affect quite a unique set of muscles. It affects the muscles around the eyes and around the mouth, muscles in the shoulder and muscles in the lower leg. What's unusual in FSHD is it sometimes affects muscles on the left side or the right side more. So most muscular dystrophies affect muscles on both sides equally, but for some reason FSHD seems to be asymmetric. There are many ideas of how you could treat FSHD. Essentially, FSHD seems to be you have a protein that is made that is not normally present in muscle, and that protein appears to be toxic. So the idea of a therapy could be to try and prevent that protein from being expressed. So if you could somehow break the gene almost, that would then stop the protein being expressed and hopefully stop the disease. Because DUX4 is toxic, it's quite hard to express it in a cell to then put a drug on to see the effect. So what we're trying to do is make models whereby we have all the parts of the gene but not the toxic part. The idea would then be that you could then put drugs on the cells. The cells wouldn't die because of the presence of DUX4, but you'd still see if the drug had an effect in controlling the expression. The project, essentially funded by MD UK, is to do with making these models. So we have collaborators in Belgium who are making these little molecular patches that will hopefully stop DUX4 being expressed. But they don't have a very good way to test this because DUX4 is a toxic protein, so when they put it in the cells can die. So what we're trying to do is make these models that we can then use to test the drugs that are being produced by other people to say, are they effective or not? And what dose would you want to put in? How long would you want to dose the animals for? Is it a one hit or do you have to keep on repeated dosing? So it's that kind of idea in the wider context.